Alright guys, so I think I got this set up right. It's been a while since we've made one of these videos, but what we're going to do today is go through this review for systems of equations before you guys take your quiz. So I'm going to describe how to do each problem, but what I want to make sure that you know is that you need to have the problems done first, right? So this is just a way for you to check yourself before you take the quiz to make sure that you're doing all these correctly. Now if you happen to miss one of these, if you're looking at me doing the answers on the video and you see that you've missed one, make sure you go back and listen how I describe how we come up with our answer for that one. Just to make sure that you really have a firm and a grasp understanding of everything before you take the quiz. Alright, so here we go. The first question here, it says, here's the graph for one equation in a system of equations. So you can see I've got this line, it has a negative slope, I can see where the y-intercept is, and I need to know what the slope is and what the y-intercept is to see what kind of system of equation I'm going to have. And it says, for the first thing, write a second equation for the system so it has infinitely many solutions. Question 1b says, write a second equation whose graph goes through 0, 1, so the system has no solutions. And then finally, write a second equation whose graph goes through 0, 2, so that the system has one solution at 4, 1. Well, I know that the two things that I need to know for systems of equations is the slope and the y-intercept. So that's the first thing I'm going to find for what we have. For this one that we have here, I can see that it crosses the y-intercept or the y-axis there at positive 4. So there's one of my points that I'm going to use to find the slope. Remember, to find slope from a graph, we're just going to draw a triangle, right? So when I draw that triangle, I count and I see that I go down 3 and to the right 4. So my equation for this, now that I know my slope is negative 3 over 4, my equation is y equals negative 3/4 x, and then it crosses the y-axis at positive 4, so plus 4. If I'm going to write a second equation for the system so that it has infinitely many solutions, it needs to have the same slope and the same y-intercept. So there we go. I'm able to, now that I can see what the slope and the y-intercept is, I'm able to come up with the exact same equation, right? And that works, okay? That works. For the second one, where it says write a second equation whose graph goes through 0, 1, so that the system has no solutions, well, I know that for no solutions, the slope still has to be the same, but it's got to go through a different y-intercept, and they actually gave that to us, right? Remember, when the x value is 0, that is, the y value is the y-intercept. So that, I know that the slope is the same. I'm just going to use negative 3/4 x again for the beginning of my equation, and for the end of my equation, I'm going to use plus 1 because it has a y-intercept at positive 1. Now, if I were to graph that to check, to make sure, I would go to 0, 1. Let me erase my line there to find the slope on that original line. But I would go to 1 on the y-axis, and then I would use the slope that I have there to double check. If I go down 3, 1, 2, 3, and over 4, 1, 2, 3, 4, there's the next point. I can't go any further, but I can go in reverse, go up 3, 1, 2, 3, and to the left 4, 1, 2, 3, 4. And now I can see, with the power of the iPad, this nice parallel line when I actually graph those points. And for the last one, it says write a second equation whose graph goes through 0, 2, so that the system has one solution at 4, 1. Now I could do this without graphing, but since we have the graph available, we might as well use it. I again want to go through the point that they give us for the y-intercept. That point is 0, 2 there. So go to 2 on the y-axis. Okay, make a point. Now it says it goes through the solution, right? The solution is at 4, 1. So if I go over to 4, 1, there's the next point that my line is going to hit. All I need to find is that slope that connects those 2 points, right? I already know the y-intercept. They gave it to us. So if I'm going to write a second equation, I need to know the slope also. Well, it looks like I go down 1 and then to the right 4. That's my slope. So my slope is negative 1/4. That's the beginning part of my equation there. Y equals negative 1/4 x. And then they told us that the y-intercept was 2. So it ends with a plus 2. All right. Moving on to number 2. For number 2, it says create a second equation so that the system has no solutions. Well, like we just said in the problem above, for no solutions, that means they're never going to intersect. It has to have the same slope but a different beginning point. So you guys could have picked anything for the y-intercept except for negative 4, because that's what's in the original equation. Now the slope has to be the same, so it has to start off with y equals 3/4 x, and then anything besides minus 4 would work for the y-intercept. So I'll use minus 3, right? Anything except for negative 4 for the y-intercept. I could even change that to a positive. Maybe I want to make it plus 3. That works as long as the y-intercept isn't negative 4. All right, go ahead and flip it over. On the back here we have Darnell and Lance are both saving money. Darnell currently has $40 and is saving $5 each week. All right, so that's his beginning point, right? He's starting with $40. He's saving $5 each week. Remember, we look for those words. That's where we're going to find the slope. Per, each, every. That's giving away the slope. So $5 every week is his slope. Lance has $25, so we found his beginning point, and is saving $8 each week. Again, we look for those words. That's telling us what the slope is. So here it says, write an equation for each boy's savings, comparing the amount of money saved, y, in terms of weeks, x. All right. Well, for Darnell, we know that he began with, we know he began with $40, so there's his y-intercept. Oops. I don't know how to get that to go away. There we go. He currently has $40 and is saving $5 each week. So there's a slope, y equals 5x, and he started with $40. For Lance, it was that he started with $25 and he's saving $8 each week. So that's 8x plus 25. And then the next thing they want us to do is graph the equations. So I'm going to do Darnell in red, and then I'll switch and do Lance in blue. Since I'm on blue right now, let's just do Lance first. So he's at 25 to begin with. Going to graph his y-intercept first. And then he's going up 8 every 1 week over. Okay, well, I know those are all multiples of 5, right? So the first one that I'm going to use is 40. $40 more than 25 is 65, and that would take 5 weeks to do. I know the next point for Lance is going to be over there at 5 weeks of $65. Go ahead and graph that. There we go. And then I'll switch to red and do Darnell. Darnell starting with $40, so I'll graph his y-intercept first. And then he is actually going up 5 every week, so I could do a point every week there. He's going up 1 over 1, up 1 over 1, up 1 over 1, until we can't go any further. Now what I've already noticed is where they're going to intersect, right? I noticed my solution as I'm graphing it. But now I've got these nice straight lines to look at. I can see that right away this is going to be a one solution type of system because they cross one time. It says, when will the boys have the same amount of money? Circle it on the graph. Boom. It's right there where they intersect, right? Solve the system of equations by graphing. That's what we did. Write your answer as an ordered pair. So for this one, oh, no, that's for the next question, sorry. When will the boys have the same amount of money? Let's actually answer that. It's going to be at 5 weeks. And how much money are they going to have? The question isn't there, but we can see it, right? I can see that they're both going to have $65 at 5 weeks. All right, now let's actually answer this question. Solve a system of equations by graphing. Write your answer as an ordered pair. So here for my first equation, I can see my y-intercept's at positive 1. I'm going to graph that first. And then it's a slope of 1/8. So I'm only going up 1 and over 8, and I can only do that once, right? Go back to my beginning point, reverse, reverse, reverse. Instead of going up, go down. Instead of going to the right, go left, 8. And there's my line. With the power of the iPad, I can draw a nice straight line. I didn't exactly hit the marks, but that's good enough. Now for the second equation, I can see it has a negative slope. And it's starting all the way up here at 6 on the y-axis. I'm going down 1 to the right 2, down 1 to the right 2, down 1 to the right 2, down 1 to the right 2. I can see where they're going to intersect. I'm going to finish out my graph though. Go back to my y-intercept, do the opposite. Up 1 to the left 2, up 1 to the left 2, up 1 to the left 2, and one more time, up 1 to the left 2. Now again, with the power of the iPad, I can draw a nice straight line. I can see where they intersect. I'm going to circle it on the graph and then do what it says, write it out as an ordered pair. So it looks like I go up, or I go over to 8. Oh, excuse me. And then my y value for that ordered pair is 2. And that is the one point that makes both of those equations true, right? It would make, there's other points that make the first equation true. There's other points that make the second equation true, but that's the only ordered pair that makes both equations true at the same time. All right. So for the last one here, we've got a pretty involved word problem. It says there's a hiking trail near the town where Han and Jada live that starts at a parking lot and ends at a lake. Han and Jada both decide to hike from the parking lot to the lake and back, but they start their hikes at different times. At the time that Han reaches the lake and starts to turn back, Jada is only 0.6 miles away from the parking lot and hiking at a constant speed of 3.2 miles per hour towards the lake. So that was a very important sentence. Han is actually on his way back. He already has started to turn back, right? Jada is still going to the lake. So right away you get this visual. There's these two hikers. One of them's going toward a lake. The other one's coming back from the lake. They are eventually going to cross, okay? Han's distance D from the parking lot can be expressed as D equals negative 2.4 T plus 4.8, where T represents the time in hours since he left the lake. What's an equation for Jada's distance from the parking lot as she heads toward the lake? So we know that she is, I'll underline that in the problem there, 0.6 miles away from the parking lot, right? So if we're trying to write an equation for her that's the distance from the parking lot, it's 0.6 as our beginning point. And then we know that she's going at a constant speed of 3.2 miles per hour. See, there's that word that gives it away again. I know I'm looking at a slope, a unit rate. Okay, so 3.2 miles per hour, that would make my equation y equals 3.2x, and her beginning point we said was 0.6. Then it says draw both graphs, one representing Han's equation and one representing Jada's equation. It's important to be very precise. Be careful, work in pencil, and use a ruler. Find the point where the two graphs intersect each other. What are the coordinates of this point? So in order to see that, let's actually go ahead and graph them. Okay, if I look over here, my y-axis is actually counting by 2/10, which is helpful for us, right? So I have to go to 0.6, so there's 2, 4, there's 6. And then for her to go up 3.2 miles every 1 hour. Okay, 1 hour is, I just want to point this out on the graph, 1 hour is all the way over here. Okay, so I'm going to go ahead and make sure that I graph this correctly. I have to go up 3.2. Well, 3.2 plus where she started at 0.6, I'm all the way up to 3.8 at 1 hour. So 3.8 and then go over to 1 hour, that is all the way up here. Okay, now it's said to be very precise, so make sure you use some sort of straight edge to graph this. Your calculator will work in most cases, okay, if you don't have a ruler available. And I'm going to leave that there for Jada and switch to blue for Han. Han is at 4.8 to begin with. Graph that all the way up there, 4.8, and is going backwards, right? He's going back toward the parking lot, so his slope is negative 2.4 per hour. So take away 2.4 from 4.8, and you're at 2.4 for 1 hour, which would be right there. So if I go ahead and draw my line, now I'm using the straight edge of the Apple Pencil, right, which helps, and then draw a straight line for Jada. I can see, I'll use a different color to circle this. I can see right where they intersect. Okay. Find the point where the two graphs intersect. What are the coordinates of this point? Well, it looks like it is 0.75 or 3/4 of an hour, and that is 3 miles away. So let's go ahead and put that down. 0.75, comma 3. What do the coordinates mean in this situation? Well, in this situation, that means, think about what 3/4 of an hour is. 3/4 of an hour is 45 minutes. So after 45 minutes, they are both 3 miles from, I ran out of space, the parking lot. So after 45 minutes, they are both 3 miles away from the parking lot. What has to be true about the relationship between these coordinates and Jada's equations? Well, it has to satisfy it. It has to make her equation true, right? Has to make the equation true or satisfy the equation. What has to be true about the relationship between these coordinates and Han's equation? It also has to make his true. It also has to satisfy his equation, right? That's what the solution does. It makes both equations true at the same time, right? It's the only point that makes both equations true. It has to make the equation true. And another way to say that is it satisfies the equation. And that's it, guys. That's the end of our review. If you're still having questions, or if you found out that you missed most of these and you don't really understand how to get them correct, make sure you ask questions. Good luck on the quiz, and that's it.